We're going over chapter 1, section 3, part 2. That is solving for variables. You can use properties to solve an equation for a variable. You can solve the equation for the specified variable. So if they want you to solve for q, you can rearrange this by adding 8r on both sides. So we get negative 5q equals 8r plus 3. Then we divide by negative 5 on both sides. And we get that q equals 8r plus 3 over negative 5. This has to do with literal equations that we had last year. In order to solve for this equation, PV equals nRT, want to make sure that the n is by itself. So we have to notice that the r and the t are both being multiplied. So I'm going to go ahead and move one first. So we divide by r because it's being multiplied. It cancels it out and we're left with PV over r equals nt. Now n and t are being multiplied, so we're going to divide again by t. And we're going to get PV over RT equals n. If you guys are able to see that you can just divide by both variables at the same time, you can go ahead and do that. If you take it one at a time or two at a time, it's fine. Just got to make sure you show your work. If you do not show your work, you do not get the points. We have C parentheses A plus B minus D equals F. You can go about it solving it multiple ways. I'm going to go ahead and do a few. The first way, or one way, doesn't have to be first per se, is I will go ahead and add the D first. And I'll get C, A plus B, parentheses equals F plus D. You can divide by C to cancel out that multiplication, and you're left with A plus B equals F plus D over C. I can subtract the B on both sides, and I'm left with A equals F plus D over C minus B. This is one way of doing this problem. Another way of doing this problem is, let me write it down first. You can distribute the C. So you can do CA plus CB minus D equals F. Go ahead and add that D. So we get CA plus CB equals F plus D. I'll subtract CB from both sides. So I'll get CA equals F plus D minus CB. Then I will divide it by C on both sides. And I'm left with A equals F plus D minus CB over C. Now I can simplify this to match the other equation because this C and this C cancel out in that term, but that does not mean it will cancel with the F and the D. So this final answer would be A equals F plus D over C minus B. So the exact same thing we had before once you simplify it. The third way you can do it is, I'm going to write it up here. I'm going to change the color so they don't mesh together. You have C, A plus B minus D equals F. You can add D first. Get C, A plus B equals F plus D. I'll go ahead and distribute that C to get CA plus CB equals F plus D. And then we get to the same step as we did in the second one. So we get CA equals F plus D minus CB. When I divide by C everything, I get A equals F plus D minus CB over C, which is this exact same step. So we can simplify it to get the exact same answer as step 2, which is the exact same answer as step 1. Again, you can choose whichever you prefer. They all should give you the same answer. Just make sure you follow the rules when it comes to rearranging the equations. So the formula for the area A of a trapezoid is A equals 1/2 height, parentheses B1 plus B2, where H represents the height and B2 and B1 represent the measures of the bases. Solve the formula for B2. So I'm just going to write it here. all they want us to solve for is B2. So they want to make sure that B2 is by itself. So in order to solve this, we want to make sure to get rid of that half or that h, because those are being multiplied into the parentheses. So to get rid of that multiplication, I'm going to actually go ahead and divide by h. So I would get a over h equals a half b1 plus b2. Now remember, to get rid of a fraction, all you have to do is multiply by the reciprocal. So the reciprocal is 2 over 1, which is just 2. So I'm going to multiply times 2 over 1. That will cancel that fraction on the right side. And I'm left with 2a over h equals b1 plus b2. Now I'm solving for b2. So the last step here will be to subtract the b1 on both sides. And I get that 2a over h minus b1 equals b2.